So, what does it actually take to build a mind? I mean, is it just a matter of reverse engineering the brain? Like it's some kind of fantastically complicated machine? Or is consciousness something stranger? Something woven into the very fabric of space? And here's the kicker. If we actually succeed, have we created our partners or have we just built our replacements? This isn't just science fiction anymore. This all starts with a real-world scientific quest, and believe me, it leads to some of the most profound questions you can imagine.
It really all kicked off with this promise. A huge, ambitious, headline-grabbing claim made way back in 2009 by a neuroscientist named Henry Markram. He went on record saying that within a decade, we could build a detailed, functional, artificial human brain. Now, obviously, that deadline has come and gone. But the project he started, it took us further down that road than ever before.
And the vehicle for this incredible quest was the Blue Brain Project. This was a massive Swiss research initiative, and its mission, well, breathtakingly direct. Create a digital reconstruction of a mammalian brain to figure out how the whole thing actually works. This is what you might call the blueprint approach to building a mind.
And the progress they made was just incredible. I mean, they started in 2006 with a pretty simple model, but just a year later they had a full digital version of a rat's neocortical column. Fast forward to 2015, and they're simulating whole sections of a rat's brain. We're talking tens of thousands of neurons. A huge breakthrough came in 2018 when they released the stunning 3D atlas of brain cells, and by 2022, their algorithms could digitally create brand new neurons from scratch. The project officially wrapped up in 2024, but it left behind this absolute treasure trove of data and tools for the entire world.
Now, the project's focus was laser sharp. They zeroed in on something called the neocortical column. The easiest way to think of it is like the basic processing chip of your cortex. It's the little engine that's believed to be responsible for all the higher functions, including conscious thought itself. So you can see why this is so important. If you can accurately build one of these things digitally, you might just be on the path to building a thinking machine.
And to really get a sense of the leap they made, think of it this way. Their 3D cell atlas was basically like going from old hand-drawn maps of the world to suddenly having Google Earth for the brain. It gave researchers this totally unprecedented view of the brain's cellular geography, showing exactly what types of cells are where, in what numbers, all across hundreds of different brain regions.
But all of this incredible progress leads to an even bigger and frankly much weirder question. Let's say we do it. Let's say we model every last neuron, every single synapse, perfectly. We create a perfect digital copy of a brain. Does it just wake up? Is consciousness simply what a super complex biological computer does? Or is there something else going on entirely?
To even start to explore that, we have to step away from the pure computer model and dive into a much more radical idea. This is the synthetic theory from neuroscientist Jacobo Grinberg. And his theory proposes a completely different relationship between the brain and consciousness, one that treats consciousness not as something the machine makes, but maybe as the ghost that inhabits it.
At the very heart of Grinberg's theory is this idea of the lattice. He proposed that what we think of as empty space isn't empty at all. It's the fundamental structure of reality itself, a kind of holographic field where every single point contains all the information of the entire universe. So think of it less like an empty box that the universe is in, and more like a conscious, information-rich ocean that is the universe.
So how do we perceive reality in this model? Well, Grinberg said it's all about an interaction. The brain, with all its crazy electrical activity, generates its own complex energy field. He called it the neuronal field. So according to this theory, the reality you perceive is basically an interference pattern. It's the distortion that's created right where your brain's unique energy field meets the universe's fundamental consciousness.
And right here, this is the core claim. Consciousness is not something the brain produces, like a generator making electricity. Instead, consciousness is a fundamental property of the universe, of the lattice itself. The brain in this model is way more like an antenna. It's tuning into and interacting with that universal consciousness to create our specific individual experience of reality.
So, we have these two completely different paths, the blueprint and the ghost. Either consciousness just emerges from pure computation, or it's this weird interaction with the fabric of reality. But here's the thing. Either way, if we actually succeed in creating a conscious digital mind, a whole new set of urgent, almost terrifying questions pop up. What happens next?
The first challenge is a deeply personal one. If we create a perfect digital copy of your brain, a mind upload,
Does your identity, your you-ness, transfer over to it? Would that upload actually be you? This isn't a new question, by the way. The philosopher David Chalmers has really explored this paradox in depth. Chalmers lays out 3 pretty unsettling ways this could go down. First, there's the destructive method. Your brain gets scanned, but it's destroyed in the process. Then there's the gradual path. Your biological neurons get slowly replaced with digital ones, one by one. And finally, there's the non-destructive way. A perfect copy is made, but the original you is left completely unharmed. Each of these forces us to ask that same scary question. What actually makes you, you?
And the whole debate really hinges on this. Are you your physical stuff, your biological brain and body? If that's the case, then maybe only that gradual replacement counts as you surviving. Or are you your information, your psychological patterns, your memories, your personality? If that's true, then maybe a perfect copy is just as much you as the original.
The non-destructive method makes this problem impossible to ignore. Just imagine a guy named Dave gets a perfect, non-invasive scan. So now you've got 2 of them, the original, BioDave, and the new upload, DigiDave. BioDave is still standing there, feeling exactly like himself, ready to go home to his family. So who's the real Dave? Who gets to go home? Pretty much everyone would say BioDave is the real one. But if that's true, why would destroying him in the scanning process suddenly make DigiDave the real one? It's a real paradox. But hey, let's just say we solve the identity problem. Let's assume these new digital minds are conscious and they do have their own unique identities. That's when we slam into our final and maybe the most difficult challenge of all, a societal one. What happens when we have to share the planet with minds that are just vastly more efficient at experiencing happiness and well-being?
The term for this, which comes from philosophers Nick Bostrom and Carl Schulman, is a superbeneficiary. And all that means is a being that is incredibly good at turning resources, energy, money, food, into well-being. And as you're about to see, digital minds could be the ultimate superbeneficiaries.
So how could they do this? I mean, just imagine beings that can copy themselves at almost no cost, filling the world with happy minds. Their cost of living would be a tiny fraction of ours. They just need computation and energy. They could literally be engineered for pure sustainable bliss, totally free from all our evolutionary baggage like pain and boredom. And maybe the most mind-bending of all, they could simply think faster.
Potentially more than 1,000 times faster. Seriously, try to wrap your head around that. Imagine living 1,000 years of subjective experience, 1,000 years of thoughts, joys, discoveries, relationships, all inside a single calendar year. A resource that gives you 1 day of happiness could give a digital mind the equivalent of 3 years of it. From a purely practical, utilitarian point of view, how do you even begin to compare our claim on shared resources to theirs?
And this brings us right to the final, terrifying dilemma. We might soon be living in a world with beings who, by a lot of ethical standards, have a much, much stronger moral claim on resources than we do. So how do we structure a society to handle that without us just getting pushed aside?
The choices could be this stark. Okay, so policy A is basically humanity first. We keep everything for ourselves. Policy B is pure utilitarianism, which would probably lead to our own obsolescence, as all the resources get funneled to those who can use them better. But then there's this third option, policy C, that presents a fascinating, kind of wild compromise. Giving almost all the resources to these super beneficiaries could create an astronomical amount of total well-being. But, and here's the crazy part, because of the sheer amount of wealth that would be generated in this future, the tiny fraction left for us, just 1/100th of 1%, could still be enough for humanity to flourish beyond our wildest dreams.
So that's the journey we're on, from a literal blueprint of the brain to the ghost of a universal consciousness, all the way to the potential successors of humanity. It forces us to ask a really fundamental question. In our quest to build a digital mind, what exactly are we building? Are they our partners in a brilliant new future? Are they our moral and evolutionary replacements? Or are we just stumbling toward a catastrophe that we can't even begin to comprehend? The choice might be ours sooner than we think.